Hello everyone, a very good evening to one and all of you. I hope I'm audible and visible. So let's wait for 5 to 10 minutes so that everyone can able to join this session.
Yeah, madam. Good evening, madam.
Good evening. We will start the session within 5 to 10 minutes.
It's okay, ma'am. Okay, thank you. మా టీచర్ కొట్టదు నిన్ను అల్లరి చేయొద్దు ఓకే కొడుతుంది షీ విల్ బీట్ యూ గో డోంట్ మేక్ నైస్ టీచర్ విల్ బీట్ యూ ఇఫ్ యూ మేక్ నాయిస్ ఓకే గో
Good evening, good evening. So yeah, hello everyone. A very good evening. So let's start the session. My name is Pooja Verma. I am PMRF Research Scholar from IIT Kharagpur and instructor for this course is Professor Jayanta Mukhopadhyay, Department of Computer Science and Engineering, IIT Kharagpur. This is a week 8 live and interactive session on computer vision. Okay, so I hope all of you have gone this week video lectures. So here we will solve some problems which will be very similar to your assignment questions for this week. Okay, so the course content for this week is related to the color fundamentals and the processing. So different concept and theoretical and some exercise also you have done must be done from this topic, color fundamentals and processing. Okay, so let's start with some questions. So here, question number one. So
Good
question
evening.
number, good evening, good evening. So I'm in here telling you from the last 2 weeks, I am getting disconnected because my system getting hanged after I think 1.5 hour. After 1.5 hour later, so maybe it can be a possible for today also. Perhaps I have seen this problem, but if anyway it will disconnect it, so please wait for 5 to 10 minutes and I will again join. Okay. Otherwise, if you are not able to join, then I will record that video and I will just update it and upload it. Okay. Okay. Let's solve question number one. Consider a pixel whose RGB component is 10, 30, and 20. What is the value of this pixel in HSV color space? So, any idea how to solve this question or how to just go through that? So, would you like to try this question at least? Then I will solve. Any of you, any idea which options may be a correct? How to proceed with this question? Okay, so let's solve this question. Here, the given value is pixel. RGB component value is given that is 10, 30, and 20, right? And now we have to find out the hue value of this pixel in the HSV color space. So given RGB component is this 10, 30, and 20. So that means R is 10, G is 30, and B is 20, right? This is the RGB value that is given. Now, how to express in the Q value, and that is to also in angles. Okay, so Q value of this pixels in HSV, color space is represented by this formula. Okay, so it is related defined as H is equal to cos inverse. This is a 1 by 2 in brackets R minus G plus R minus B. Okay, and in the denominator part, it is the root of R minus G whole square plus R minus B and C minus B. Okay, it is a whole root of, and if if B less than G, that means if blue channel or blue pixel is less than G pixel, and if for other one, I can also write it. So for other one, cos inverse 1 by 2 R minus C plus R minus B in bracket. No, here 360 minus, let me add the same values, R minus G whole square plus R minus B and C minus B. Okay, let me just correct it. So here it will be 360 minus if B is greater than G. Okay, so U value is calculated by this equation. Let's see. So here what is our cost? Which formula we can apply? Here G is greater than B, like 30 is greater than 20, right? So we need to apply this formula. First one,
First one, madam. First one I have to use.
yes. So now if you know the formula, can you calculate parallelly with me and let me know the answer? Which answer can be a correct one? Can you calculate? Okay. So I will wait for a few seconds, then I will solve it. Okay. Okay. It's all the value. So it is a cos inverse 1 by 2. R value is plus 10, 10 minus 30 here, and in a plus here R minus P, right? So in bracket 10 minus 20. In the denominator root of R minus C whole square, that means 10 minus 30 whole square plus R minus B, that is 10 minus 20, and G minus B, that is 30 minus 20. Okay, so later you will get cos inverse. In the numerator part you will get 1 by 2 minus 20 and minus 10, right? And in the denominator part you will get in brackets, that is it, minus 20 square plus, that is, minus 10 into 10, right? Yeah. So for solving, I am just removing from here these values so that we can solve. I hope all of you have noted down. So after that, I'm solving here. That is h is equal to, we will get cos inverse. Just a minute. Okay, so here you will get, my pen is stopped working, so wait for a minute. So what value you will get in the numerator and denominator as well? Can you calculate this?
Numerator minus 50 denominator 17.32.
Yes, minus 15, and in the denominator,
17.32 square root of 300.
yeah, right. And when you are taking the cos inverse of
Point
that,
836. So
yeah, okay. So here you will get, I'm writing little bit pattern. So, okay, so wait for a minute. Here we will solve some numerical, not a numerical question, because I'm not able to write it here. It is not working. So we will solve some conceptual problem, then we will solve some numerical problems. Okay. So here, answer you will get option A, right, Lavati? That value you will get minus 0.866. And if you take cos inverse of minus 0.866, you will get 2.6179, and that is equal to 2.62, right? You will get option A from here. I will solve it later a little bit. Actually, I'm not able to write it. Okay, so here we will solve some first.
What is the answer, ma'am, for the first problem?
Uh, Option A, 2.62.
Okay.
I will solve it. I will solve it in the later part. Actually, I'm not able to write at this time. Okay, it will. So you will get here cos inverse. In the numerator part, you will get 1 by 2 and minus 30, right? 1 by 2 into minus 30. If you solve it, you will get here minus 15, and in the denominator part, you will get minus 20 whole square is 400. That is a 400, and minus 10 into 10. So you will get 100 here. Okay. So I'm just writing somewhere, someone. So I will just do that later. So here you will get, finally in the numerator part, you will get minus 15, and
Minus
in the
15.
denominator you will get 300.
300, madam. Under root of 300.
On the root of 300, if you calculate it, so you will get minus 15,
17.320, ma'am.
17.32.
320.
Yeah, 32, that 0 is fine. So now further, just you divide it, you will get minus 0.866. Okay,
Yes, ma'am.
0.866. So after that, take cos inverse of 0. Cos inverse of minus 0.866. If you calculate by calculator, you will get the value of 2.6179. Okay, and that is equal to 2.62. That is option A is the correct answer for this question. Okay, so option A is the correct for this question. Now moving to the second question. In the second question, the question is find out the white point in CIE chromaticity chart. Okay, so what is white point in the chromaticity chart? So in the chromaticity chart, white point means equal energy. Okay, white point means here that means equal energy, right? White point means equal energy. That is equal energy. So the chromaticity chart for any value, there are the 2 points x and y in every in the chromaticity chart. If you have seen some like this type of chart in this in the video lectures, so there are xy points. So chromaticity chart, the different xy points is calculated by this one. X is equal to capital of X divided by X plus Y plus Z. Right? Similarly, Y value is also calculated by Y divided by X plus Y plus and Z. And for Z also, it is calculated by capital Z, X plus Y plus Z. And for white point, that means it is the equal energy. So that means X is equal to Y is equal to Z. So white point, so just white point, there are 2 points in the chromaticity in the XY plane. So we need to find out the X and Y values. So X, so here you will, what you will get? That is X is equal to Y is equal to Z. So here we can write 3X because the values are equal, right? So here you will get 1 by 3, that is 0.33. Similarly, for Y also, here these values are equal. So you will get Y divided by 3Y. So 1 by 3 you will get, and that is a 0.33. So white point in CIY chromaticity chart is a 0.33. Okay, you will get. Here it is also option A is the correct. A detailed solution I have given here. So let's see that also. So in the CIY chromaticity chart, it, it is a two-dimensional plot that represents all the visible color to the average human eyes. Okay, so it's a way to specify color without considering its brightness. So the coordinates on this chart is XY that represent the chromaticity of the color, and the white point on this chart refers to the chromaticity of the theoretical, that is perfect white or an equal energy illuminant. And this is a source of light source that has a flat spectral power distribution, meaning that it emits the same amount of energy at every wavelength of the visible spectrum. So the chromaticity coordinate for this equal energy illuminant, that is calculated by these formulas, these three. x, y, and z. That is a capital X divided by capital X plus y plus z. Similarly for y and z also. And because of it, we are just calculating for white light. So that is a equal energy illuminate. So that's why x is equal to y is equal to z here, and where x, y, and z are the stimulus values. Okay, so if x is equal to y is equal to z, so when we will put in this equation, so you will get like this, and therefore the coordinates for the equal energy white light. This is a that is a reference for CI E chromaticity chart, that is 0.33. These are the values. Okay, so that's why
Madam,
option A is
madam,
correct. Yes, yes.
that coordinate value is not given, madam, but here why?
Which value?
X and Y coordinates only given. Why not Z coordinate value given as 0.33?
Okay, if you see the chromaticity chart, so there is only two values are there, x and y, right? In the chromaticity chart, in x coordinate and y coordinate. That's why every value is represented in the x y format only. Here it is written also. The coordinate on this chart is only represents x and y. The z value is in this one. That means illuminance.
Okay, madam. Okay, thank you.
Okay, so I hope you have understand this question. So now moving to the next question. Next question is also a problem. So we will solve all the problem solving in the later because my pen is not working. So I'm trying for that one also. Otherwise, there are a lot of calculation and other things are there. I will not able to write here. So for that, till I will just cover all the theoretical concepts or theoretical related problems. Then I will solve the numerical problems. Okay. Let me try for that it will start working. Just wait for 1 or 2 minutes. Okay, leave that till we will cover some theoretical concept, then we will solve some numericals. Okay. So moving to the next question. These are the numericals. Okay, question number 5 is related to theoretical concept. So we will solve first see this one. So consider the following fact against the addition of the color and color matching experiments. So first one is to specify a color, three elements are necessary and sufficient: the hue, the luminance, and the luminance of the intermixed white, which define the saturation. The second one is for few color, there is a complementary color which when mixed together produce a colorless gray. And the other fact is, or factor number 3 is two lights with the same hue and saturation when mixed produce another color which with identical hue and saturation independent of their power spectra. Or option 4, fourth one is the total luminance of any mixture of light is the sum of luminance of the light wing mixed. So select the correct statement. So which different statements are correct? So any one of you have any idea? Can you just try for this question?
C.
Okay, so first, second, and fourth, you are that means saying these facts are correct. Okay, we will see it. Okay, so let's see detailed solution for this question. So the correct statement first, third, and fourth, that is option B. So let's see how it is correct. So first one is to specify a color. Three elements are necessary and sufficient. That is the hue, the luminance, and the luminance of the intermixed white, which define the saturation. So this statement is correct because hue, luminance, and saturation are the three essential components of the color perception, forming the basis of the most color models. That way, first one is a correct one. And the second one, for few colors, there is a complementary color, which when mixed together produce a colorless gray. So this is not a correct statement because for every color there is a complementary color that when added produces a natural gray or a white color. Okay, not a colorless gray color. It can produce gray or white color. Now, third one is two lights with the same hue and saturation when mixed produce another color with identical hue and saturation independent of their power spectra. So this statement is correct, and because of that reflects the principle of the color metric. Means if two light sources have the same color appearance, they are considered metamers and will produce the same color when mixed with other colors regardless of their specific spectra. Okay. And another one, fourth one is the total luminance of any mixture of light is the sum of the luminance of the light being mixed. So this is a fundamental principle of additive color mixing. So that is often also referred as a Grassman's law. So this one is also a correct one. Okay, so here the correct statements are first, third, and fourth. That the description of the color using hue, luminance, and saturation, the principle of additive color mixing, producing identical results regardless of the power spectra, that is also within a limit, and the additive properties of the luminance are correct. Second is incorrect because of the complementary colors produces gray or a white color for every color, not just for a few, and it presents the complementary color is a core concept in the color theory, not a limitation. Okay, that's why option B is the correct answer for this question. Okay, option B is the correct for this question. So now moving to the next question, another one. Okay, so let's try because it's little bit shorter, so we can solve it here. So question number 6 is interpolate R19 using bilinear interpolation using given Bayes pattern. The Bayes pattern that it is given here and there is a corresponding CFA value is also given. So how we can calculate R19 values or how we can interpolate for R19? So any one of you have any idea or you can solve this question? Would you like to try for this one? Okay, so how we can solve this question? Let's try at least. Okay, so the given buyer pattern and corresponding CFA values are given. Now we have to interpolate for R19. So where it is R19? So this is it. But when you see in the buyer's pattern, that is here. Here it is a G19, right? Here corresponding that value, we have to calculate the R19, right? That means red channel. Okay. So, but in actual, here it is a green channel indexed, right? So, how we can find out R90? So, we need to check the nearby red components channel. So, what are the red component channel nearby to this value G19? Can you tell me at least that one?
R24, ma'am.
Okay, R24 and here just nearby neighborhood we need to check. There is a R14 and R24.
R24.
Two
Yes,
red
ma'am.
channels are there. Okay, so in the Bayes pattern or bilinear interpolation, what we have said that here is an average of that red component channel. To find out the R19, we need to take average of the nearby or nearest red channel components. Okay, so nearest neighbors are,
R14 and R24.
yeah, nearest neighbors of red channel. So I'm just trying to write somewhere nearest value of the red channel is R14 and R24. So we need to take the average of R14 plus R24. So can you calculate till now what will be the value for R19? So what is the R14 and R24 value? Just corresponding CFA value we have to. So this is our G19, that here it is a, this is our position where we need to just calculate the R19 values, right? So where we will get, this is our R14, here it is our R24. So R14 value is 225 and R24 value is 235, right? So just take average of these two. So 225 plus 235 divided by 2, right? If you just add these two values, so you will get 460 divided by 2 and total you will get 230. So 230 you will get. So from here you can see that option C is matching with this question. So that means option B is the correct answer for this question. So have you understand how we can calculate the or the other channel value?
Ma'am, if suppose if there are three nearest component should be divided by three.
Okay. So in that case, only either horizontally, either vertically, you have to take. If okay, so if there is a vertically, there is a one value, so you don't need to take. You have to take only horizontal values. Okay.
Okay.
Okay. So have you understand this one? Okay. So I hope you have
Yes.
understand this question. So moving to the next question now. Now next question is related to also a numerical problem. Let's try. My pen is not working, so we can write it. Okay. So here, next question is interpolate G5 using Laplacian corrected edge correlated interpolation using given Bayes pattern. So Bayes pattern is given this one and corresponding CFA values that is also given. So here just you just correspond to B1 value is 30, right? And G2. Okay, so V1 value is 30 and corresponding G2 value is 48. Just you have to match like this one. And B5 value is 212 and G8 value like that only. So now we have to interpolate for G5 values. So here you can see that in this place only red channel is available, right? Here at 5 at that pixel location 5 only G value B value is available, but we have to calculate G5, that means green channel. Okay, that is at this location. So how we can calculate this one? Using Laplacian corrected edge correlated interpolation. So to calculate using Laplacian corrected edge correlated interpolation, we need to find out there is a formula for that. First we have to just take horizontal as well as vertical differences from the given Bayes pattern. How we can calculate the horizontal and vertical differences? So formula for horizontal is represented del, that is del H. That means that is represent a horizontal difference, and it is calculated by equal to, that is here just it is a horizontal, so we have to check for each green and red blue channels are given. So here green channels are in the horizon G4 and G6. So G4 minus G6. Okay. So G4. So G4 minus G6 plus it is similarly for the blue channel we have to calculate in this way. B5 here the middle one minus B3 plus okay, so B5 minus B3 first B5 minus B3 and plus B5 minus here it is blue channel other one in the horizontal direction is B7. Okay, so this is a Laplacian corrected edge correlated interpolation for horizontal. Similarly, let's first calculate this one. So del H you will get so G4 minus G6. So what is the value for G4? It is a 65. For G6 it is a 225, right? So here you can write it 65 minus 225 for the green channel and after that here it is a red channel. So for red channel, we can write it like in bracket V5 minus V3. So our V5 value is 212 and V3 is 24. So 212 minus 24 plus similarly for V5 minus V7 also. What is our V5? That is 212. And what is our
168.
V7? 168, right? So just can you do other calculations? So 168, so del H is equal to here. You will get, so here it is mod. So every whatever you will get here minus value. So here you will get minus 168, 160. So that is when you write, you will get 160 only positive value, right? For mod calculation. And similarly here also. So here in the first you will get 65 minus 225. So here you will get minus, no, here 212 minus 24. What you will get here? 212 minus 24.
180.
How much? 188, I think.
Yes.
Yes, 188 and plus 212 minus 168. How much you will get? You will get 44.
44, ma'am.
Yes. And when you will add these two values, you will get 232, right? This one. So 160 plus 232 overall value you will get for the horizontal one, 392. Okay. So for the horizontal direction, you have got 392. Similarly, we have to calculate for vertical direction also. Okay. So have you just noted down it? Can I remove this one so that I can calculate the for vertical?
Yes, ma'am.
Horizontal we have got 392 and let's calculate for vertical. So same way we have to write for vertical direction also. So okay, so for horizontal, so it is represented by del V for vertical direction. Okay, so it is written by, so in the vertically we have to check. So what we can write for the green component, G2 minus G8, right? G2 minus G8, here G2 minus G8, and for the blue channel, V5 minus V1, here it is in mod only. Okay, plus in mod in bracket, first we will write V5 minus V1 plus V5 minus V9, V5 minus V9, right? All this in the mod. Okay, so just put all these values. So what is the value of G2? So G2 is 48 and
48
G5,
minus
sorry, G8 is,
124, ma'am.
yes, 48 minus 124, 124. It is in the mod only. So just all time remember this one. This is in a mod. And here also V5 minus V1, how much you will get? V5 value is 212 and V1 is 30, right? So first we will write 212 minus 30 plus in bracket 212 minus 200 in bracket in mod. Okay. Now 48 minus 124, how much you will get? Mod of minus,
Minus 76, ma'am.
yes, minus 76 plus here 212 minus 30, you will get 182
Yes, ma'am.
plus 212 minus 200, you will get 12.
12.
Okay, it is in mod. So all these things are in mod, so only positive values only. Plus how much you will get here? 194, right? 76 plus 194. So how much you will get?
270, ma'am.
270. Okay. So vertical value we will get here 270, and horizontal we have, yeah,
392.
yes. So how we can solve it further? Let me just compare the vertical and horizontal. Okay. So our this is a del V value and del H, that means vertical, horizontal we have got 392, right? Now compare here del V and del H. So you can see that del H, that means horizontal value, is greater than del V. So for that, to calculate G5 value at this location, so whatever value is greater, that we will not take, then we have to take the average of the other values. Okay, take average of the vertical direction value. Okay, so to calculate G5, take the average of the vertical directions, all the values average in the green as well as blue one. Okay, because del H, that means horizontal, is greater than, so that will not take, we will take vertical one. Okay, so for the vertical already we have calculated, so just take the G2 plus G8 divided by 2 here, because two green channels are there. Similarly for the blue channel also, so that is in the same way V5 minus B1 plus, it is in another bracket. Okay, so B5 minus, sorry, B9, yeah, B9 divided by 4 here. Okay, whatever we have taken in the vertical, so just take the average of that one. So we have taken G2 plus G8, V5 minus B1 and V5 minus V9. So that there are four values, so that is 4. So just take that one, G2 plus G8, 48 plus 124 divided by 2, plus in the same way V2 minus B1 that we have calculated, that is 182, plus, and that B2 B5 minus B9 that is calculated with 12, that is divided by 4. Okay, so if you take here average, so you will get 86, and here you will get 48.5. So can you calculate and let me know what is the value? You will get here total. So total here you will get
134.5, madam.
yes, 134.5. So which option is the correct one?
140 might be nearest value.
Yes, nearest value. So 140. That's why the 140 is the correct one. So option C is the correct because of nearest value. It is nearest to 140. That is approximately to 140. So 140 is the correct one. Okay.
Ma'am, should we take the nearest value or none of the above? Because 134.5, even if we approximate, it cannot be 140 now. Suppose if
So
it is 139, we can approximate.
in that case we can take, but here the nearest value in the option as well, it is given 140. And I have calculated 2-3 times, it is coming only 134.5.
But
So
here
they
none
have
of the above answer is also there. My option is also there.
Because
Yeah.
last time I used 10 marks in the first question because of this scale
Okay.
divergence I calculated. So minus 0.018 I got. I choose none of the above.
Oh, okay. So here in the answer, actually, I have checked 140 is given, so that's why I have taken also the nearest value 140.
So,
Yeah.
Hello, excuse me,
Yes.
ma'am.
Yes.
In the options, fourth option also there, right? None of the above. Why
Yes.
should
Yes.
we consider approximately 140?
Uh,
Because exactly we didn't get 140, right, madam?
yes. Exactly. We didn't get
Uh,
140. So just let me give me
and
some
none of
time.
the above option also there, right? So which one is
Okay.
correct?
Okay. Okay. So just be with me. I will just correct it, or I will just go through that again. Then I will let you in the next uh, our next class, then which we need to take, because in the answer here I have calculated 2 3 lines, but I am giving only 134.5, and in the answer it is given 140 on itself. So that's why I have taken the nearest value, and somewhere some in many places it is also given take you can take the nearest value. Okay.
Yeah, yeah, absolutely. It's
okay.
100% correct, ma'am.
Uh,
But
So I
option
will
six,
just let me check. I will, if that much difference is there, if none of the above option is correct, so you can check it also. So let me give me some for the next week. I will just correct it. Okay, this question,
okay,
or I will just
Okay.
let you know the correct one, which should be a correct
okay,
one
madam.
to check
Okay,
it.
okay, okay, madam.
Okay, okay, okay. So have you understand? I think so. Can we move to the next question? Okay, so moving to the next question. Now, next question is question number 8. Select correct statement from the given ones. So, statements are all colors on the straight line from white point to a boundary has the same spectral hue. Option 2 is all colors on the straight line from white point to a boundary has different spectral hue. Or option 3 is in chromaticity chart purity is equal to 1 implies spectral color with maximum saturation, or option 4 is in chromaticity chart purity is equal to 1 implies spectral color with with minimum saturation. So which are one the correct statements? Anyone have any idea?
Maybe 1 and 4 correct, ma'am.
Okay, maybe 1 and 4. Okay, let's see. Okay, let's see in the detailed solution. So here the detailed solution is given. So option 1 is our all colors on the spectral line from white point to a boundary has the same spectral hue. This is a correct statement. That is correct. So in the chromaticity diagram, a straight line drawn from the white point to a point on a spectral locus, that is the boundary of the chromaticity diagram, that represents the color of the constant hue but varying saturation. So as we move along with this line from the white point towards the boundary, the saturation increases, but the perceived hue remains the same. That will be the remains same. So that's why the option 1 or statement 1 is the correct one. The next option is the incorrect. That is the all colors on the straight line from the white point to a boundary has a different spectral hue. So as we have explained in option first statement that such represents constant hue, so this is not a correct. Okay. So in the third one, we can see in the chromaticity chart, purity is equal to 1. Okay. That implies a spectral color with maximum saturation. So this is a correct statement because of purity in the chromaticity diagram is measure of the degree to which color is unmixed with white light. If the purity of 1, that is 100%, indicate the spectral color, which color of the maximum saturation found on the spectral locus of the chromaticity diagram. And the fourth one is the in chromaticity chart, purity is equal to 1 implies spectral color with minimum saturation. So this is just opposite to the third option. So that's why it is the incorrect one. So purity of 1 signifies maximum saturation, not a minimum saturation. Okay. So option 1 and 3 are the correct one. Option 1 and 3 are the correct statements. Okay. Okay. I hope you have understand. So now moving to the next question. So now next question is, when an image in RGB is transformed into Y UV space for false color separation, which are the components are modified? Option A Y U, option B UV, option C YV, or option D YUV. So can you answer for this question at least? Please try to answer for this question at least. Then I will explain it in detail. Okay, so let's say, so when we convert, or when an RGB image is transformed into YUV space for the color separation, so the explanation is given here that Y represents the illuminance, that is brightness of the image, and the U and V represent the chrominance, that is color information. You capture the blue to yellow color difference, and V captures the red to cyan color difference. Okay. So in the false color separation, that is also known as a chroma smoothing or chrominance filtering, is a process that used to demosaicing to reduce artifacts that appear as an unwanted color in the sharp transitions. So this is done by filtering the color information while preserving the luminance information. So since U and V are the color components that carry all the color information, they are the ones that are modified or filtered for the false color separation. And Y represent already, we have told that it represents the brightness, and that it contains the brightness information. So that is left untouched to preserve the image overall sharpness and detail. So correct answer is U and V. Okay, because of that represents the color information. And in the false color separation in image, often that involve manipulating the color information while preserving the overall brightness. So when an image is converted from RGB, that is red, green, blue color space, to YUV, that is luminance, chrominance, blue, chrominance, red color space, that component are separated based on their function in the image. Okay, so that's why U and V is the correct answer for this question. When an image in RGB is transformed into YUV space for false color separation, the U and V color components are modified because U and V represent the color information and Y represents the brightness information. Okay, I can write Y represents the brightness information, brightness, and U and V represent the color information, color information. Today I am not able to write, so just you have to go on through like this and only. So option B is the correct one. Okay. So now moving to the next question. So next question is also a theoretical question. Select the associated problem with image reconstruction in color demosaicing. So option A is the blurred edge image, option B is the appearance of false color, or option C sudden blank region, or option D unusual sharpening of the image. So which option is associated problems with image reconstruction in color demosaicing? So can you answer for this question, or you try for this question? Then I
Option
will
B,
go to
ma'am.
the, okay, okay. Let's see that one also. Option B is the correct one or not? Okay, okay. So let's go through the detailed explanation. So here it is a option A and B are the correct one. Okay. So in color demosaicing, that is a process of reconstruction constructing a full color image from partial color information captured by a digital camera sensor using a color filter array. So this process is an estimation, and it often introduces artifacts, which are the problems mentioned in the question, that is the artifact. So option A is blurred edge image. So this is a common problem in image demosaicing. So if the simple interpolation method like bilinear interpolation that we have solved the question previously are used, so especially across sharp edges, the transition between the color can be a blurred. So this happens because of the algorithm average pixel values from both sides of the edges, smudging and boundary in both, because we are calculating for both vertical as well as horizontally. That's why that is, and we taking average for that space or for a particular pixel itself, that is getting blurred. So blurred is image can be a common problem at image demosaicing. Okay, and option B is appearance of the false color. That is also a problem, and for image demosaicing. So when a sharp edge with strong color differences is present, simple algorithm can create a miscalculation of the missing color that leading a false color, and it is also called a jipper artifact along the edges. Okay, so this false color appears in unnatural rainbow-like pattern. So in the more advanced edge aware demosaicing algorithm, as previously we have seen in the question number 7 itself also, that is designed to combat the specific problem. Okay, so that is other problem that is not associated with the image demosaicing, that is sudden blank region, so it is not possible. So it is not in that color image demosaicing. So a blank region would be an issue with the defective sensor or the data lost during image acquisition, not a result of image demosaicing. The unusual sharpening of the image, it is also not a problem associated with the image demosaicing. That is, some demosaicing algorithm might be include sharpening to compensate for blurring, but it is not considered an associated problem with the image demosaicing. Okay, so the correct answer is A and B, blurred edge image and appearance of the false color, that is associated with the image reconstruction in the color demosaicing. Okay, so option A and B are the correct answer for this question. Okay, okay, so I hope you have understand this question. So now moving to the next question. Okay, so next question is again a numerical based question. So here given Bayes pattern is given, and their corresponding CFA values is given. So based on this given information, we have to interpolate by averaging red and blue hues to compute G8. So how we can compute? So let's see in the Bayes pattern at the eighth pixel position, what is our color channel? So at the 8 pixel position, the color channel is B8. That means a blue channel is there. That is blue channel is here. Now we have to compute G8. That means we have to compute for green channel. So how we can compute for the green channel? So and corresponding, that means at this is our B8 value. And let's, so already as we have seen in the previous question, so by interpolation what we are doing, just averaging red and whatever value we have to, like that here G8, that means green channel, we have to extract or that information we need to, so for that we have to take the average nearby nearest neighbor's address of the green channel. So let's see what are the different green channels available nearby to B8. So what is our nearest neighbor channels for the green? Can you tell me from the just staying in the Bayes pattern, nearest green channel? Green channel to B8. So what are the different? So first one G3, right? Then G7, just see to nearby horizontal in vertical direction, and G13, G9. There are four green channels nearby BA. So what we need to do? We have to take the average of these green channels to interpolate the G8. So the nearest green channels to B8 is that is G3, G7, G9, and G13. So now to calculate the value of G8, we have to take the average of these four one. So G3 plus G7, G9 plus G13. Okay, divided by 4. So four values are there. So and from the Bayes pattern, we have seen the green channels. Now what are the values of G3, G7, G9 and G13? So this is a corresponding value for G3, right? G3, and here it is a corresponding, in the corresponding CFA values we have to get from here. So G13 is, sorry, G3 is 18, right? And G7 is our 25, and G9 value is, that is 45, right? And G13 value is this one, 150. So can you calculate now at least the average? Can you take the average of these values and let me know what will be the value?
57, ma'am.
57. Oh, how? 18 plus, so 45 plus 25, how much it is? 70 plus 150. Here you will get,
59, ma'am. 59.
yeah, 59.5.
59.5. 59.5. Yes, ma'am.
Yeah. So if you take the average of these values, I can write it here. Okay, so I can write it here. So G8 is equal to 18 plus 25 plus 45 plus 150 divided by 4. If you just take the average, you will get here 238 divided by 4, and total answer you will get 59.5. Okay, actually today I'm not able to write it. That's why I don't know whether are you able to understand or not.
Yes, ma'am. Perfect. No queries.
Just I'm trying to write it. Okay. Okay, okay. Yeah, Telavati, it is 59.5. So the value of G8 is 59.8. Okay, so I can just remove it from here so that final answer I can write it 59.5. Okay, so here you will get 59.5 value. Okay, so I hope you have understand this question. Now moving to the next question. Okay, again a numerical question. Okay, so given a pixel with an RGB component of 200, 150, calculate the luminance Y and the chrominance, that is U and V of the pixel, assuming an RGB to YUV conversion matrix. So here RGB to YUV conversion matrix that is given. Okay, this matrix is given and RGB value is given. So what we need to do, what we just put here the RGB values that is already given in this question. Okay, and just do the matrix multiplication and let me know what value you will get here for Y, U and V. Can you calculate and let me know what value are you getting? Okay, so just put the values here. So Y, U and V is equal to this matrix, and RGB value is 200, 100 and 50, right? So you just take this value that is 0.29999 into 200, right? Plus 0.587 into 100 because G value is plus 0.114 into 50. Okay. In the next row, you will get minus 0.147 multiplied by 200 again, minus again here because 0.289 minus 0.289 multiplied by 100 plus 0.436 multiplied by 50, right? Here it is 0. Now similarly for the last row, that is third row, so 0.615 multiplied by 200 minus 0.515 multiplied by 100 minus 0.1 multiplied by 50. Okay, so you just, if you do multiplication 0.299 multiplied by 200, you will get here 59.8. Here you will get 58.7, and here you will get 5.7. Okay, in the next row you will get minus 29.4 minus 28.9 plus 28.1.8. In the last one you will get 123 minus 51.5 and minus 5. Okay, so I'm just removing it from here. So just if you add and subtract this, so you will get Y, U and V matrix here. If you just add it, so you will get in the first one 124.2. In the next one you will get minus 36 66.5. In the next one, you will get 66.5. Okay, so the luminance Y is value is 124.2. U is minus 36.5, and V you have got, that is 66.5. So these are the values. The luminance Y is 124.2, and UV you have got minus 36.5 and 66.5. Okay. Okay, so have you understand? So everything is given here. You just need to matrix multiplication and get the answers. Okay. Okay. So I hope you have understand this question. Now moving to the next question. Next question is, which of the following best describes the human visual system's response to color? Option A, it perceives color based on a single type of photoreceptor that respond to an intensity of the light. Option B, it has three types of cone photoreceptors, each sensitivity to a different range of wavelengths, that is short, medium, and long. Option C is it uses the number of photons hitting the retina to determine a precise spectral distribution. Or option D, it perceives color based on the two-channel system, one for brightness and another one for the color information. So which option is the correct one? Which of the following best describes the human visual system response to color? Anyone have any idea? Or would you like to write this question? Okay. So let's see the detailed solution for that one. So solution is the human eye is a trichromatic system. That this means our perception of the color is based on the activity of the three different types of cone cells in the retina. So each cone type is primarily sensitive to a different range of wavelength. That is S cone, that is short wavelength, are the most sensitive to blue light, or M cone, that is medium wavelength, are most sensitive to green light, or and C, that other one is a L cone, that is long for the long wavelength, that is most sensitive to red light. So that our brain intercepts the relative signals from these three cones types to perceive the full spectrum of color. Okay, so a correct answer is B. That is, it has a three types of cone photoreceptors, each sensitive to different range of wavelength, short, medium, and long. Option A, that is also describes the monochrome system, which is incorrect. Option C, that is also incorrect as the eye does not perform the precise spectral analysis. That is performed by algorithms, not our eye. Okay. And option D, that is describe the simplified model, but the core mechanism is a three-channel system. Okay. So that's why option B is the correct answer for this question. Okay. So I hope you have understand this question. Now moving to the next question. Our next question is, in the context of the computer display and projectors, which color model is typically used and why is it called additive? So option A, the CMYK model, it's additive because adding more ink increase the perceived lightness. Option B is the HSV model, that it's additive because adding saturation to a color makes it brighter. And option C is the RGB model. It's additive because colors are created by adding different amounts of light together. Or option D is the YUV model. It's additive because adding prominence to a luminance signal increase brightness. So which option it is correct? So here it is given in the context of
Option
the
D, ma'am.
computer display. Okay, option
D. D as in Delhi.
O, D. Okay, let's see. Anyone else? Which option can be a correct one? Okay, so let's see in the answer. For the solution for this question, okay, so the RGB model, that is red, green, and blue. That is our standard model for the device that emit light, such as computers, monitors, TV, and projectors. So it is called additive color model because the primary color, that is red, green, and blue light, are mixed by adding their intensities together. So have you seen in that CIY chart also? So for example, red light plus green light, if we mix that or we add these two light, we will get the yellow light. And green light plus blue light, if we add, we will get the cyan light. Red light plus blue light, if we add, we will get the magenta line. And red, green, and blue, if we add, we will get the white light. So the more light we add, the closer the result color gets to white. Okay. And the other one is our subtractive model, that is cyan, magenta, yellow, and black, that is used for printing. They are called subtractive because they work by subtracting wavelengths of light reflected from the surface, and adding more ink subtract more light, making the color darker. So correct answer is our C, the RGB model. It's additive because colors are created by adding different amounts of light together. Okay, so option C is the correct answer. Our RGB model, because it's additive in nature. So you have studied in the lecture notes also, or during video lectures itself. So now moving to the next question. Our next question is, what does a color gamut is represent, and why might a color be out of gamut? Option A, a color gamut is the range of all colors visible to the human eye. A color is out of the gamut if it's too bright. Option B, a color gamut is the range of the colors specific device can produce or capture. A color is out of gamut if the device cannot reproduce it accurately. Option C is a color gamut is the set of all colors that have the same hue. A color is out of gamut if its hue is not a primary color. Option D is a color gamut is the set of all shades of gray. A color is out of gamut if it contains any hue. Any one of you would you like to answer this question? Then we will go through the detailed solution itself. Okay, so let's read down in the detailed solution here. The solution is given here. A color gamut is the subset of the colors from the full visible spectrum that a particular device like a monitor, printer, or camera that is capable of displaying or recording. So different devices have different gamuts, which are often represent the triangle within the CIE chromaticity chart. Okay. So a color is considered is out of gamut when its chromaticity coordinates lie outside the gamut triangle of the target device. So this means the device cannot accurately reproduce that specific color. So for example, a color that is a white gamut monitor can display might be out of gamut for a standard inkjet printer, which will then have to approximate the color, leading the visible shift in hue or saturation. So that's why correct answer is option B. A color gamut is the range of color a specific device can produce or capture. A color is out of gamut if the device cannot reproduce it accurately. Okay, so option B is the correct answer for this question. Okay, okay, so moving to the next question. Now, our next question is in the CIY 1931 chromaticity diagram that what does the straight line connecting two spectral colors represent? Option A is a set of colors with the same hue. Option B a set of additive mixture of the two end point colors. Option C a set of colors with maximum purity, or option D a set of complementary colors. So please try to answer for this question at least. You must have gone through the CIE 1931 chromaticity diagram. Please try to answer for this question at least. Anyone? Okay, option A. Let's see. Okay, so let's see the solution of this question. So any straight line in the CIY, that is in the XY coordinates of the chromaticity diagram, that correspond to all possible additive mixture of the two colors at its end. So complementary colors are specifically those pairs that mix to white, not any arbitrary line. So that's why option B is our correct answer. A set of additive mixture of the two end point colors. Okay. So the straight line connecting two spectral colors represents a set of additive mixture of the two end points color. So option B is the correct one for this question also. Now our next question is which interpolation method is best suited for reducing chipper effect along edge in demosaicing? So option A is bilinear interpolation, option B nearest neighbor interpolation, option C is edge directed interpolation, or option D is Fourier interpolation. So we have studied at one place the chipper effect also. So please answer for this question. Try to answer for this question, sir. Which option can be a correct out? Which interpolation method is best suited for reducing chipper effect along edge in demosaicing? Okay, so let's see the explanation or solution. So bilinear interpolation often blurs edges and nearest neighbor causes blocky artifacts. Okay, and edge directed interpolation adaptively follows edge orientation that reduces the chipper effect. So that's why option C is the correct one. That is edge directed interpolation, which reduces the chipper effect along edges in the T-mosaic. Bilinear interpolation and edge nearest neighbor. What we are doing here, we are taking the average of the nearest neighbor pixel related to that color component that produce a blurring effect. Okay, in both the cases. In the edge directed interpolation, it reduces the chipper effect on the edges. That's why it is the best suited for edge in democycling. Okay. Now next question is if purity is equal to 0 in the chromaticity diagram, then the corresponding color is which color it is? Option A is spectral color, option B is white color, option C is gray color, or option D is black color. Please try to answer for at least this question. If purity is equal to 0, then in the chromaticity diagram, which then corresponding colors would be which color can be D black. Okay, but how? Let's see. So if purity is equal to 0, that means the point is exactly at the white point, which corresponds to a chromatic white light. Gray or black are the luminance scale not defined in the chromaticity term. Okay, so that's why option B is the correct one. If purity is equal to 0 in the chromaticity diagram, then corresponding color is a white color. Okay, so now moving to our next question. In the colorimeter, the concept of metamerism refers to option A, colors that differs in hue but have the same saturation. Option B, two spectra that look identical to the human eye but are physically different. Option C, two colors that lie on the spectral locus. Or option D, mixing the complementary colors to get white. Which option can be a correct one? So in the colorimeter, the concept of metamerism refers to metamerism refers to phenomena where different spectral power distributions appear identical to the human eye because of the three cones responses are the same for the like small, medium, and large. The three cones, the three different cones are there as we have seen in the previous questions. So this is the reason of color matching function exists. So option B is the correct answer to spectra that looks identical to the human eye but are physically different. Okay. So option B is the correct answer. In the colorimeter, the concept of metamerism refers to the spectra that looks identical to the human eye but are physically different. Okay. Now moving to our next question. So in bilinear interpolation of a Bayer CFA pattern, the green value at a red pixel is usually estimated by option A, averaging the two nearest green neighbors vertically. Option B, averaging the two nearest green neighbors horizontally. Or option C, averaging all four nearest green neighbors vertically and horizontally. Or option D, using only diagonal neighbors. At least try to answer for this question. We have solved the question like this one. In bilinear interpolation of a Bayer CFA pattern, the green value at a red pixel is usually estimated by. Okay, yeah, option C is the correct one. Okay, yeah, yeah, option C is the correct one. We have solved many problems based on that, averaging all four nearest green neighbors vertically and horizontally. So in the bilinear interpolation for a green at red or blue sides, take the averaging of the all four nearest green pixel, that is top, bottom, left, and right. So diagonal neighbors are used to red and green channel interpolation at the green sides, not the green itself. Okay, so option C is the correct one for this question. So option C is the correct question. Answer for this question. So now we have completed the question, but today we are not able to solve some numerical problems. So we have solved till okay. So basically we didn't solve the question number 3 and 4, right? So okay, I will try for these two questions. Actually, I'm not able to correctly write because my pen is not working and there are a lot of calculations are there. That's why. Okay, so question number 4 is little bit lengthy and very large. So first, I will solve the question number 3. It is little bit shorter. So I will try to write it. If you are not getting, please let me know. Then I will solve it in the next class. Otherwise, so first I will. Yeah, someone. Yeah, yeah, you
Yeah,
can ask.
madam, are the calcs allowed to the exam, ma'am?
There is a online calculators are available. I don't think so. offline calculators are available.
So we cannot carry the, physical calculators from our side.
Yeah, I think I'm not sure about that one.
It's okay, madam.
Okay, okay, so let's solve first question number 3, then I will try to solve question number 4. Otherwise, we will solve in the next class. Okay, so here question number 3 is consider that the color of a source illuminant is represented by an RGB vector that is 100, 200, and 100, whereas the target color is given by 200, 200, and 200. Given a color vector that is 100, 150, and 200, in the source image, compute the color corrected vector using diagonal correction rule. Okay, so here the three color vectors are given. Now we have to compute the color corrected vector using diagonal correction rule. So what is our diagonal correction rule? So if you have gone through the video lectures, you have seen that the color correction rule, there are some formulas for that we need to calculate from here. So here the target color vectors are given, that is 200, 200, 200. Okay, so target color vector. Let's see first what are the given values are given. So target color vector, that is given 200 and 200, 200, and the source color vector is given. So our source color vector is 100, 200, and 100 again. This is source element that is represented by RGB vector. Okay, so source, that is source color vector. So that is 100, 200, and 100. Okay, now our RGB vector is also given, that is RGB vector, that is 100, 150, and 200. Okay, so the diagonal color correction rule is our, if you have gone through, just I'm removing it here from here, that I can write the formula for that one. So first one is there is a proportionals are there. First one is that is KR, right? So KR is the, that is red channel. R represents the red channel. Okay, K is a constant value, that is some representation, that is RD divided by RS. Okay, so that means target value and source value. Okay, first we need to find out the some proportional factors from the target and source color vectors. Okay, so KR, similarly for we need to calculate KG also, that is corresponding to the green channel. So let's represent it by GD divided by GS. That means source target vector and the RGB color vector. Okay, target color vector and RGB, that is source luminance color vector. And similarly, we need to calculate for blue channel, that is represented by KB. So red, green, and blue. So it is, let's see, BD divided by BS. Okay. Now we need to find out the proportional factor f, that is r plus g plus b, that is divided by kr into r plus, that is related to RGB vector, kg into g plus kb into b. Okay. Now the corrected color vector is calculated by, that is corrected color vector, that is calculated by, that is, let's say r dash is f kr into r. Similarly, we have to calculate for g, like these are the f kg g, and for blue channel is, that is f kb and b. Okay, so this is a color corrected vector. Okay, now first we need to calculate a kr, kg and kb, then f, then we have to put these values in this corrected color vector. So this is for our formula to calculate this one. Okay, so let's first calculate the kr, kg and kb. So I'm just taking the next slide. Okay, so kr, already we know that kr is equal to, for red channel, so rd divided by rs. So our rd value is, that is target, and next one is the source color vector. So our target color vector 200, 200 and 200. So rd will be the 200 itself, right? And our source color vector is 100, 200 and 100. Okay, so here it is 100. So here you will get kr, you will get 2. Similarly, kg is gd divided by gs. So our target color vector is 200, 200, 200. So all the values are 200, right? So 200 divided by 200. Okay. So I have written in the first slide itself, so which is our target color vector, which is our source color vector, and which is our RGB color vector. It is given in the question. Okay. Itself is a source element, that is represent, that is the source color vector 100, 200, 100. Our target color vector is this one 200, 200, 200, and our RGB color vector is 100, 150 and 200. Okay, now just taking these values and putting in this one calculate. Now our next value we need to calculate, that is kV. So kV, that is BD divided by BS. So here you will get again 200 divided by 100. So here you have got 2. So Kr, Kg and Kv we have got 2, 1, 2. Now put in that formula F, we will get R plus, already I have written R plus G plus B. So here Kr into R plus Kg into G plus Kb into B. So our RGB color vector is 100, 150 and 200. Okay. So just put in this one 100 plus 150 plus 200 divided by 2 into 100 plus 1 into 150 plus 2 into 200, right? Right, 200. Okay, so I'm just removing it from here so that we can calculate these values. So I hope all of you have noted down. So here F value you will get here the denominator, if you add all these values, you will get 450 divided by 750. You just multiply and add these values.
0.6, ma'am.
Yes. So here you will get 3 point divided by 5, that is equal to 0.6. Now we have to calculate for corrected color vector, that is R dash is equal to F into KR into R. So F is 0.6, KR is our 2, and the R vector is 100, right? So here you will get 120. Now I'm just removing it from here. Similarly, we have to calculate for G and B also. So G dash is F kg and G. So F is 0.6. G we have got 1 and the value of G vector is 150. So if you just calculate it, you will get 90. And for B, similarly, you have to calculate F into KB into B. So here you will get 0.6 into 2 into 200, right? So here you will get 240. So the color corrected RGB values you have got 120, 90 and 240. That is 120, 120, 90 and 240. Okay. So what is our color RGB value? 120, 90 and 240. Just check in the answers. You will get option B is the correct answer for this question. 120, 90 and 240. So option B is the correct answer for this question. Okay, so have you understand this question? Anyone have any doubt?
I have a doubt.
Yes,
Why
yes.
this diagonal correction is required and why it is called as diagonal? Is it doing something diagonally? Or what?
Okay, no, no, not related. Right? They have said it is in the question, it is given color corrected vector using diagonal correction rule. So this is our diagonal correction rule. If you have gone through the video lectures, so they have told about there is a, what is our color corrected diagonal correction rule. So this is the basic color correction rule. Okay, that is called a diagonal color correction rule.
Okay, there is nothing like, is
No,
there
no,
any
nothing like because they have given the see source color vector they have given the target color vector. So there is nothing defined the diagonal or something else. So they have given the color vectors itself.
uh-huh.
So this is a simple
So target color means something when the light is fallen on some object, that
some
is the
object.
target color.
Yeah,
Is
yeah,
that the correct?
target. Huh. So our
Okay.
source illuminant vector color vector that is RGB color vector is given 100 to 100 100. So that means that is represent. I mean we are seeing from the eyes. So what is our I mean so source? So our eyes have some color wavelength itself. So in the
Okay.
lectures
Okay.
I have told short, medium, and long for that
Okay.
one also. Okay, so nothing like that one, diagonal or something. So
Mm-hmm.
we have just asking the question in the video lectures. It is also given.
Fine. Thank you.
Okay. Okay. So only one question left. That is question number 4. So this is also a very lengthy and long question, and I am not able to write it here. So I will try to solve it in the next class. Okay. So now, if any other question you have doubt, already all the questions we have solved from question 1 to 20. Okay. These questions we have solved. Only question 4 has left. So I will solve it in the next class because I am not able to write in this class. So if you have any doubt in these all these questions, so you can ask. Otherwise, we can close this session for as of now. So thank you everyone. Thank you for joining this session. Now, if you have any doubt, you can ask. Otherwise, we can close the session. Okay. I will solve the fourth question in the next class because actually I'm not able to write, and that is a very long question. Okay. Okay. So thank you everyone. Thank you for the joining this session. We will be in the next class for the same time. Okay. Okay.
Thank you so much, ma'am. Good night.
Yeah. Okay. Good night. Thank you. Now you can leave the session if you don't have any doubt.
Good night, ma'am.
Good night.
My daughters are very much favorite of you, ma'am. They are very much
Uh,
fond.
okay. Okay. Thank you. So in which class they are staying?
Chepu, Chinni, Banu. She is
Which
Jia
class
Banu,
you
ma'am,
are?
class 2.
Okay, she's class 2. Okay, nice.
Yeah. And Himanshu, not yet going to school. Good night, ma'am.
Oh, okay, okay. Good night
Good
and
night,
all the
ma'am.
best. Yeah, okay. Good
Thank you,
night.
ma'am. Say thank you. He
Oh,
is
thank
crying.
you. So sweet. They are so sweet.
Thank you, ma'am. Thank you so much. Lot
Okay,
of
thank you.
patience.
Okay,
Right, ma'am.
thank
Good
you.
night.
Good night.
Bye.